Hello everyone, and welcome to this demonstration. This is a demonstration case our Matis team has specially built for our Recloser products. Next, I'll introduce each product for you. First, let's open the demonstration case. We'll plug the power cord for the case into the socket. We can see that the power indicators for all the devices have successfully turned on. As you can see, the inside of the case is divided into 3 rows. The first row contains our 3 main products, the MT53AI, the MT51AI, and the MT51SD. These are our 3 recloser products. Then in the second row, we can see some switches, buttons, and other components like indicator lights. These are used to demonstrate the control functions. I will demonstrate these in more detail for you later on. Here in the bottom left corner, we have a screen. This screen is for the remote control console, for remote control of the devices. This is for the 485 control, and this is our PLC module. This is our power supply module. The main purpose of the power supply module is to provide a 24-volt power supply for our PLC. Okay, so now let's first take a look at the MT53AI product. The MT53AI with 3-cycle fixed logic auto-reclosing. It uses a 3-cycle fixed program. The first time it waits 10 seconds, the second time it waits 60 seconds, and the third time it waits 300 seconds. After each successful reclosing, it enters a 50-minute stabilization period. As long as any reclosing is successful and there are no fault trips within that stabilization period, the system will automatically reset and return to the first reclosing logic. The MT51AI with customizable reclosing logic and an alarm output. It supports customization of both the number of reclosing cycles and the reclosing time to meet the needs of different field applications. We can see there are 2 rotary dials on the product's front panel, an upper and a lower one. Each dial has 10 selectable positions. They correspond to the reclosing time and the number of reclosing cycles respectively. For example, if I want to customize a program with 2 reclosing cycles with a 10-second delay each time, referring to the parameter table in the product manual, I need to turn the number dial to 2 and the time dial to 1. At this point, we'll manually close the breaker. When an unexpected trip causes the circuit breaker to open, we can see the indicator light on the device starts to flash. This means it has now entered the reclosing delay sequence. After a 10-second delay, the device will perform its first automatic reclose. The LCD screen shows the number of reclosing cycles that have already occurred. When the fault occurs again, the device once again enters the reclosing logic. After 10 seconds, the device is successfully overlapped for the second time. The LCD screen displays that the overlap count has reached 2. When the number of overlaps reaches the upper limit I set, the device will notify the console via alarm output and simultaneously exit the automatic reclosing logic. For example, another malfunction and disconnection. The indicator light will remain constantly on and an alarm will be output to the console. How do we reset our overlap count and time? We first need to, in the Mayday AI mode, switch one knob to the look mode, then press and hold the reset button. We continue until Yejinping's number is returned all the way to 0, and then we switch our dial back to auto mode. Thirst. The MT53 AI uses I/O control and has AUX status output. We will demonstrate this using a button. When the load button is pressed, the feeder will perform a check and the indicator light on the device will turn green. Simultaneously, feedback will be sent to the workbench and the indicator light on the workbench will illuminate. When the trip button is pressed, the circuit breaker will trip and the indicator light on the device will turn red. Simultaneously, the A and X statuses are fed back to the workbench and we can see the indicator lights turn off. The MT51 AI uses a single node I/O control method. We will demonstrate the tripping and closing operations using buttons. When the click and add button is pressed, the device will perform a clamping operation. When the split button is clicked, the device will split the clips. Okay, first let's take a look at the automatic realignment function of our MT5 LSD. Our first knob is a selector toggle for the automatic realignment setting. According to the user manual, I'll set the knob to position 3 for now. The three parties represent the 6 automatic resynchronization cycles the device will perform, and the time for each of these 6 resynchronization cycles: 10 seconds, 20 seconds, 30 seconds, 60 seconds, 100 seconds, and 300 seconds. Then we see that I connected 2 sets of indicator lights. Our Alt1 indicator light is a status feedback output indicator for the MT5SD, indicating whether the MT51SD is currently in a nuclear explosion or a partial explosion state. My Alt+2 output value represents a fault feedback indicator. That is, there will be feedback if an insulation fault occurs in the circuit or automatic reclosing fails. Now I will simulate a fault sharing. We can see that the red light on the device panel starts to flash, which means that it is entering the waiting overlap procedure. At the same time, our Alti+ indicator light is now lit, indicating that the device is currently in a nuclear explosion state. If I apply an 8000 ohm resistor to the device, that is, the MT51SD will perform an insulation check on the circuit before auto-reclosing. We can see our LT2 indicator, the green light, turns on. At the same time, the yellow light on the device itself stays on solid. This indicates that an insulation fault has occurred. The device will not auto-reclose. Only after I release my hand, when the 8000 ohm resistor is no longer in the circuit, will the device then re-enter the waiting procedure for reclosing. At the same time, the OUT2 light turns off. So why are we using a momentary switch here to simulate this with an 8000 ohm resistor? Because if we were to use a maintained switch in the closed state, if the user forgets to release it, it would continuously cause the resistor to burn out. Now let's do another demonstration. We apply an 8000 ohm resistor to the circuit and hold it for an extended period. Before auto-reclosing, it will perform an insulation check on the circuit. It detects the circuit resistance is at 8000 ohms. We can see our OOT2 output, the fault feedback light is on, and at the same time the yellow light is on solid. When it's released, it re-enters the auto-reclose waiting procedure. Next, let's take a look at the demonstration of the MT41SD's control functions in its various modes. First, we see on the device's dial panel, there is a second knob. This is the control mode selector knob. First, we'll turn it to mode A under the RC1 mode, the RC1A mode. In RC1A mode, I've selected two types of switches for this demonstration: a maintain switch, a momentary switch, and also the RS485 control from the console. First, the maintain switch. When I press it, we can see the device closes. Then I press it again and the device opens. Similarly, for the pulse type switch, the momentary switch, one pulse closes the device, another pulse opens the device. Then my RS485 control. I give it a close command and the device closes. I give it an open command and the device opens. This means that in RC1A mode, my MT51SD has three control methods: RS485 control, maintain switch control, and momentary pulse control. These three control methods can be used interchangeably, meaning I can use the maintain switch to close it, and I can use the remote RS485 to open it. I can also use RS485 to close it and use the switch to open it. By the same token, I can use the momentary switch to close it. I can also use the RS485 to open it remotely. This concludes the demonstration for the RC1A mode. Next, we'll switch our control mode. We'll switch the control mode to the RC2A mode. The dial is turned to the RC2A mode. For the RC2A mode, I'm using a 3-position rotary switch for this control demonstration. When C1 is on, the device closes. When C1 is off, the device opens. When C1 is on, we can see the device closes, but the RS485 control is not permitted. This means remote control is disabled. Only when we turn the key switch to the C2 on position, we can see that the device does not automatically close. It can only be controlled remotely via RS485 for both opening and closing. In other words, this is a local override control mode. That is, only when C2 is on will your RS485 be permitted to perform remote control. Finally, let's summarize our three recloser products. MT53AI with three fixed program automatic reclosures plus remote control and expandable options for RS485 and Wi-Fi control. MT51AI with customizable reclosure counts and timing, plus remote control and alarm output. The remote control is expandable with an RS485 control option. Finally, our MT51SD. This is the most full-featured product with the most diverse control modes. It has a 10-step automatic reclosure program, plus installation monitoring, remote control, and alarm output functions.